Welcome, everyone, to today's Explainer. I'm your host, and today we're shining a spotlight on a crucial part of education that, well, honestly, usually happens behind closed doors. We're diving deep into Chapter 9, Test and Assessment Analysis by Ake Pakiti. And let me just say, the stakes here are incredibly high. We aren't just stamping grades on a paper. We are literally making decisions that shape students' academic and professional lives. It all comes down to accountability. To help me unpack this whole mini lecture, I am absolutely thrilled to have two fantastic co-explorers with me today. First, we have Sarah, a postgraduate TESOL student who is deep into the theory, and David, an early career language teacher who is right there in the trenches grading papers as we speak. Welcome, you two.
Thanks so much. I've got my notebook completely ready to go.
And I've got a massive stack of ungraded quizzes sitting on my desk, so let's get into this. All right, here's our quick roadmap for the explainer today. We're going to cover 1. Why analyze assessment data. 2. Making sense of statistics. 3. Item analysis for better tests. 4. Reliability of subjective scores. 5. Differential item functioning, or DIF. And finally, 6. The value of qualitative analysis. Let's just jump right in. Section 1. Why analyze assessment data? So I actually want to jump in with a really foundational question right off the bat. Why do we even need all this complex analysis after a test is already designed, administered, and the students have gone home? I mean, isn't the hard part over by then? That is literally the perfect question to start us off, Sarah. To answer that, let's rewind for just a second to Chapter 4. Remember when we talked about the standards and qualities of an assessment? Big concepts like validity, reliability, and fairness? Well, those are really just theoretical ideas until we actually prove they exist in our tests. That's where Chapter 9, Test Analysis, comes in. It provides the empirical evidence. It's the proof. Because without analyzing the data, we're basically just crossing our fingers and guessing that our test was fair and measured what it was supposed to measure. Analysis gives us the hard, undeniable data we need to back up our educational decisions. Okay, moving to Section 2, Making Sense of Statistics. I am totally on board with the why now. But as a teacher, I get this raw data dump from a classroom of 30 students, and honestly, it can look incredibly intimidating. How are we supposed to even begin making sense of all those numbers? Totally understandable, David. But don't worry, we always start with descriptive statistics, just to get a holistic view. It's pretty straightforward. The mean is your average, the median is the middle score, and the mode is simply the most frequent score. But the real heavy hitter here is standard deviation.
Right, and that measures score variance, doesn't it?
Exactly. It tells us if your students' scores are homogeneous, meaning everyone scored roughly the exact same, or heterogeneous, meaning the scores are all over the place. Think about it this way. If your standard deviation is 0, literally every single student got the exact same score. I keep hearing people talk about the bell curve when standard deviation comes up. What does that actually mean in practice?
A normal distribution illustrates this perfectly. Picture a perfectly symmetrical bell shape in your mind. That center line, right down the middle, is our mean score. Let's say it's 70. Now, the bulk of the bell shape represents one standard deviation, which let's say is 15 points. This means a huge chunk of your students, roughly 68% of them, scored between a 55 and an 85. It's just a really great way to visualize how scores spread out symmetrically around the average ability level.
Okay, that makes sense. But what if I want to go a step further and compare two entirely different classes? Or, say, figure out if my brand new teaching method actually worked better than the old one?
For that, we have to step up to inferential statistics. We use specific tools, things like the t-test or ANOVA, to infer relationships in the data.
Oh, and is that where the famous p-value comes into play?
Spot on. A p-value of 0.05 is what we look for to prove that our outcomes are statistically significant, meaning they didn't just happen by pure chance. And hey, for anyone stressing about the math right now, don't. Modern statistical software manages all these massive datasets for us today. It really frees up educators and assessment professionals to just focus on identifying the strengths and weaknesses in their tests.
All right, Section 3, Item Analysis for Better Tests. Statistics are great for the macro level, but I want to pivot to the micro level for a second. What about my actual Friday quizzes? How can I use this data to evaluate specific multiple choice questions? Because sometimes I feel like I wrote a brilliant question, but then almost everyone gets it wrong. Welcome to the world of item analysis. The most fundamental metric we use here is called the Item Difficulty Index.
It sounds fancy, but it is simply the proportion of students who answered a specific question correctly. So if 80% of your class got it right, the index is 0.80. Now, here is the absolute secret sauce you need to remember. The ideal target range for a test item is between 0.40 and 0.60. If it falls right in that pocket, it means it's perfectly challenging. It's not a total breeze, but it's not impossibly hard either. So it's basically the Goldilocks zone for an assessment.
Wait, hold on a second though. If a question has a difficulty of 0.40, that means 60% of the class actually got it wrong. How do we know if it's a genuinely fair, difficult question or if it's just a really poorly written trick question?
That is brilliant, Sarah, and it leads us directly into item discrimination and distractor analysis. We essentially need to know if a difficult item is effectively separating our high performers from our low performers. Now, in a multiple choice question, all those wrong answers are called distractors. A well-written distractor should trick the students who genuinely don't know the material, without confusing the high-performing students who do know it. We are looking for a point by serial index of greater than 0.25 for our distractors. To put it bluntly, if your top students are all picking option B, but option B is supposedly the wrong answer, well, you don't have a student problem, David. You have a poorly written test item.
Ouch. Okay, message received. I will definitely be checking my distractors a lot more closely from now on.
Let's move to Section 4, Reliability of Subjective Scores. Everything we just talked about makes total sense for a multiple choice quiz. But what about performance assessments? You know, grading essays or judging speaking tests? It gets so subjective. How can I possibly ensure any kind of fairness and reliability when I'm just staring at a massive stack of writing assignments?
It's a great point. We actually measure this in two very distinct ways. First, there's intra-rater reliability. This is just about you, David. Do you grade the exact same essay the exact same way on a fresh Monday morning as you do on a tired Friday afternoon? Then there's inter-rater reliability. That's checking if you and a fellow teacher would agree on the grades for the same stack of papers. And what happens if the correlation between the graders falls below that 0.70 mark we're usually aiming for? Well, that right there is exactly why rater training and moderation procedures are so absolutely critical. Assessment developers rely on these procedures to improve scoring accuracy, reliability, and fairness across the entire board. It keeps everyone calibrated.
Okay, Section 5, Differential Item Functioning, or DIF. I actually have a big concern here about systemic bias. What happens if a test item is statistically reliable on paper, but it's secretly disadvantaging a very specific demographic group? Like, what if there's a cultural reference in a reading passage that only a handful of students would even understand? Sarah, you've just hit on one of the most vital, game-changing areas of modern psychometrics. This is differential item functioning, or DIF for short.
What exactly is a diff analysis looking for, though?
It catches situations where two test takers who have the exact same language ability but come from different groups have a totally unequal chance of success on a specific item. Catching diff is crucial because it identifies what we call construct-irrelevant variance. To put it simply, it literally prevents discrimination from sneaking into our testing. Wow, so if a reading test item accidentally requires knowledge of, say, American baseball rules, it would get flagged in a diff analysis if we compared international and domestic students.
And we categorize these factors really carefully. We analyze concrete groupings, which are things like gender, ethnicity, or age. But we also look at latent groupings. These are the hidden traits, like test anxiety or maybe a student's computer skills if it's a digital test. A truly fair test guarantees that only a student's actual language ability dictates their score, not their cultural background or how anxious they are.
Section 6, the value of qualitative analysis. Now, all this statistical data is incredibly powerful, but raw numbers and p-values don't really tell us why a student struggled, do they? It kind of feels like we are missing half the picture here.
You are entirely right, Sarah. And that bridges us perfectly into qualitative analysis.
The numbers show us exactly where the problem is, but qualitative data shows us why it's happening. Just listen to this quote from a student named Liang taken during a cognitive interview about a writing task. He said, "I have to read the question prompt carefully. I use my background knowledge to brainstorm." Interviews, diaries, and direct observations like this are amazing because they reveal the hidden mental processes of our test takers. It tells us how they are actually interacting with the test we designed in real time.
I genuinely love getting that kind of verbal feedback, but how on earth do I organize all those messy, unstructured comments from my students without losing my mind?
That's where we use thematic analysis. It's just 4 steps. Step 1, you collect your data, whether that's interviews or diaries. Step 2, you code the responses, basically tagging the important keywords.
I'm guessing step 3 would be identifying the broader themes from all those codes, right?
Precisely. And finally, step 4, you interpret those findings to physically revise and improve your test. It's a structured way to turn highly subjective feedback into concrete, actionable data.
And just like that, that brings us to the end of our roadmap. We've journeyed all the way from the raw, hard data of descriptive statistics to the very human element of qualitative interviews. David, Sarah, thank you both so much for joining me on this deep dive into Chapter 9.
Thank you. Seriously, I am never going to look at a multiple-choice distractor the same way ever again.
And I am absolutely running an item difficulty check on my quiz this Friday, for sure.
I absolutely love to hear it. So here is our final key takeaway for everyone watching. Test and assessment analysis provides the vital empirical evidence we need about the quality of our instruments and our score interpretations. By examining item performance, reliability, validity, and rater behavior, we can improve our tests immensely. So my final question to you is this. How will you use assessment analysis to transform your own classroom tests into robust instruments of evidence? Think about it, apply it, and we will see you on the next explainer.